right. Hi, everybody. It's time for the next session. Let me introduce you to Stephan. And take it away, Stephan.
Thanks. Hi, I'm Stephan, working at weSystems. This is actually my second year with the second talk at the CCC 2024. Really happy to see all of you over here. I have to say, it's an interesting topic. And I'll be talking about CloudStack Networking in action. And this is meant to be inspirational. When we started at weSystems with CloudStack quite 4 years ago, I wish I would have known a lot of this before and during planning, because that's what CloudStack offers such a lot of features, and mostly is about planning, getting features right, getting features right for your requirements actually. So I noticed that during my last talk as well, that giving ideas is a lot helping. Giving inspirations is a lot helping, and seeing how others do things in CloudStack is helping a lot. So all the things I will show today is how we use CloudStack networking at weSystems. It can be right for some of your challenges you're facing, but take that as an inspiration to think further and develop your ideas. That's the idea of it. At weSystems, what do we do actually? And that aligns then as well with how we do networking or why we do things as we do. We are actually split into, we offer computing services, specifically going from colocation to infrastructure as a service, that is our cloud offering, to fully managed services, and to voice services as well. Well, all the other ones as well, but voice services as well. So based on our platform, we provide voice services for our customers as well, which are low latency services, and even half a minute of downtime matters for voice customers, because a drop phone call is a drop phone call, right? And CloudStack, let me first ask you, who is just about to getting started with CloudStack? Great. And who's with CloudStack for quite some years already? So we have another few people in here. What about you?
I don't know, only networking.
Yeah.
In my company, they work with CloudStack, but I manage the network infrastructure.
Okay.
So I'm in the middle.
Great. Yeah. Whenever questions appear, just raise a hand. I think we have enough time to answer questions during the talk as well and at the end. Within CloudStack, you probably have seen it already or heard about it or read about it in the documentation. We have those briefly three tiers of or the three types of networks. It's the isolated networks, which usually you present your virtual machines with non-rooted or private IP addresses. You usually deploy it with a so-called virtual router, which provides a lot of functionality and is helping as well with what we saw before from Perl with the CKS, for example, so with a lot of features and integrates, and all the networking functions. Then we have layer 2 network type, which can be used to communicate with resources outside of CloudStack, or can be used, we will see that later, can be used as a stupid. So a network without any functions, without any functionality as a network in CloudStack. And we have a shared type of network which helps to combine or to connect resources of different organizational units, either it being multiple customers or it being different departments of a customer of your company. And at the very start, I stumbled across those three and thought like, okay, that's what I will work with, that's what I will deal with, and try to map the challenges we were facing onto those three types of networks. But then I digged into templates or service offerings for networks, which then opens the whole new world of getting into the depth of it and being able to customize your networks actually. So you can define your bandwidth for that, for this specific type of network. You're able to specify if this network should provide any networking functions like DHCP, like DNS, like network address translation, or any of those, all of these, you can particularly choose them. And very important for the layer 2 mainly, ability to, if you are able to specify a specific VLAN for that network. Because usually CloudStack takes one of the available VLANs you defined at the setup phase and works, or VLAN or VNI, depending on which concept you're using. But you are able to specify a VLAN, which will be of very much of a help later. And you are able to limit the availability for specific network types to organizational units, to domains, to specific customers in our case. And of course, define the service offering for the system or for the virtual router. The very easy quick start, very likely, anyone who has ever worked with CloudStack very likely came across the typical isolated network which provides the virtual router. So it's an easy start for customers, no specific knowledge about working with firewalls, working with routers is required. Customer can deploy the virtual machine, connect it, and it's ready. So it's a really easy start, really helping with those customers. It provides a lot of features like the integrated firewall, the integrated load balancer, the integrated VPN functionality, and automatically assigns a public IP address to the virtual router and private IP addresses to the virtual machines. Using NAT or using network address translation, helping to make those virtual machines accessible or have them access the outside world. And all of that is integrated into the web UI, into the API. So really, the most easy start for customers we can think of. And just in a really simple drawing, we have the virtual machines, we have the isolated network with services, so with a virtual router. That's the standard case in that part. For example, using a /24, and you have the integrated virtual router the customer does not have to take care of. It's just there, and it just works. And the customer can decide if opening a firewall port in the UI or the API, but no specific network appliance knowledge is required. This type of network, this isolated network, can actually do way more. And who has ever worked with the CKS, so with the CloudStack provided Kubernetes cluster? I see 3 hands. That's something. CloudStack has a very easy way of deploying or having a Kubernetes cluster ready to use deployed on your CloudStack. That works really well for a really easy case. Just a few nodes deployed on CloudStack, and you have a ready-to-use CloudStack Kubernetes cluster. But for our case, we required a bit more. But first, the isolated network with the CKS comes with a virtual router. Because the virtual router, again, provides the functionality for DHCP, for network address translation, and that is mandatory for the CKS, also for the built-in Kubernetes cluster in CloudStack. So we use an isolated network, but in our case, we spice it up with the specify VLAN functionality, so we can define a very specific VLAN which we are aware of and which will not change even if the virtual router is recreated. And we split the subnet. I will have a nice picture of that one on the next slide again. But what we actually want to achieve, we want to use external storage for the Kubernetes cluster. So in Kubernetes, you can define, or you probably want to have persistent storage as well. And persistent storage is usually attached via CSI, the storage interface. And just imagine we have a Ceph cluster, or all of our Kubernetes, or all of our platforms are based on Ceph clusters, and we want to attach Ceph storage to the Kubernetes cluster. Usually, the only way in and out of the virtual machines of the Kubernetes cluster is a virtual router. Well, but probably you don't want to have a virtual router doing NAT or whatever is in there between your virtual machines, between your Kubernetes host and the storage. You want to have at least hosts as possible, and you want to have the lowest latency as possible. So we had to find a way to actually get away out, or find a network path out of the isolated network, directly attaching it to the Ceph cluster. And I will just jump to the picture, makes it easier. I can show from the other side actually. So what we use an isolated network, which provides the functionality of the virtual router. So we have the firewall, the NAT, the load balancer, everything what is required for the CKS, for the managed Kubernetes. But we specify a VLAN. In this example, it's 3001. And this VLAN we do know. And this VLAN we can configure on our external switches and on our external router. But usually the virtual router takes care of providing IP addresses within this network. So with the API, the update network command, I think, you can split, or you can define or tell the virtual router which IP address should you use for your DHCP pool. So we split this network to /24. We split it into 2 times /25. The first part of the network will be used by the virtual router to provide IP addresses to the worker nodes of the Kubernetes cluster. And the second part of the /24 network will be used for all of our external services. So we actually define a gateway IP within this network. We define the gateway on the external router, which is, in our case, is a hardware box. And then are able to route directly in ASIC, route directly to our storage nodes. So using that idea, we keep all the functionality of the Kubernetes cluster, which is built into CloudStack, but still have the way to the outside world, to the storage. Well, usually these worker nodes don't know about how to reach the Ceph nodes in this case. So we use a trick using a daemon set where we deploy host routes to each worker node, and each time a worker node is added, it will get the daemon setter, or will get the pod with the daemon set as well, and will know the Ceph nodes I can reach via the external router. So just by providing the functionality of specify VLAN and splitting the network, we now have a totally different concept, and we were able to enrich the Kubernetes network with a CSI, or the Ceph CSI, to directly access the storage with the lowest latency and less hops. Because routing storage traffic through the virtual router, or nothing else through the virtual router, would slow down access times. Then we have the shared network. We use the shared network when we want to connect resources of different organizational units, either being different customers or being at different platforms of a single customer. I've been showing it on the portfolio. We are building platforms based off colocation resources, infrastructure service resources, and completely managed resources. And still, the managed resources and the infrastructures of the service resources can be of the same customer. So for example, the customer would like to have their development infrastructure. They want to deploy their own virtual machines. But for the managed part, for their managed SQL, for their managed whatever is there, they want us to manage it. So it's two different domains actually in our cloud stack, but we connect them with a shared network and suddenly have them connected. This one, exactly. That changed a little bit as well with the network permissions, which was introduced in one of the last versions, so that now a customer can share a network between between organizational units within their domain. So that makes things a bit easier, but for our case, where we have two different domains for one customer, one being for the managed services, one being for the infrastructure service services, then we still use the shared network. I see a lot, and I will come back to that one later as well. On the user mailing list, I see a lot of questions. Hey, how do I provide public IP addresses to virtual machines? And in many cases, recommendation is using shared networks, which in our case does not work because we do use advanced zones. And in advanced zone without security group, we saw it earlier, that will change or is changing now. But without security groups, well, the customer could simply specify a public IP on their own, which actually belongs to another customer. That can be solved by fixed MAC IP entries on the router, but well, that comes with a lot of effort in the end. So we are not using that concept actually to provide public IP addresses to customers. And I mentioned the layer 2 networks. Layer 2 networks we use mainly for layer 2 networks with ConfigDrive and without specified VLAN. I have another one for that. We use it for, just a stupid network for multi-tier applications, for example, in CloudStack. First, as a very simple example, having application servers and connecting them to database servers, where we do want to use static IPs without any DHCP, DNS, or whatever functionality, just a plain network. I always recommend, even if you don't know about how to, or if you need it later, but I always recommend for layer 2 networks using or checking the ConfigDrive option. What actually is happening there, when you have a network without a virtual router, then you cannot you're missing a way to provide user data to a VM. So cloud init scripts will not work anymore. So you cannot provide data to the virtual machines during the setup phase. But with ConfigDrive, CloudStack is just creating on the fly, creating an ISO file, including your user data, attaching that to the virtual machine which is deployed, and boom, you have the same functionality again. So every time, for every kind of layer 2 network, for every type of network where we don't, or where I do not plan to have a virtual router, I always check the ConfigDrive. And this one, like the simple networks, just without any functionality, without specified VLAN, we have CloudStack managing the VLANs out of the pool we provided it with, and with that one we don't expose those VLANs to external resources. So it's isolated within CloudStack. It's isolated tier for those multi-tier applications, and without any functionality. How am I with the timing? I lost overview.
Like 10 minutes or so.
Okay, fine. And that's our way of providing public IP addresses, either it being IPv4 and IPv6. I would say that at the end, that might change now with what Wei is talking about tomorrow with static and dynamic routing, which is introduced in 4.20. That's currently the way how we provide IPv4 and IPv6 to VMs. We use that for layer 2 or shared networks. In that case, it does not matter. We do not use the virtual router, so no functionality like DHCP, DNS, and NAT. But we do use, again, ConfigDrive, because we don't have a virtual router, and we specify VLAN. what we actually do is, or where we do that a lot, is when the customer requests to have public IP addresses on the virtual machine. That is the case for running virtual firewall appliances, virtual routing appliances. You do not want to have NAT in front of that. You want to have the public IP address. And again, we check the specify VLAN, and that allows us to configure this VLAN on external resources, on external storage, on external router again, and yeah, gives us the possibility to configure the gateway on an external router, and have public IP addresses assigned directly to virtual machines. Let me show that in a drawing. Sorry?
Is that a shared VLAN for everyone? So every customer has...
No. Every customer has still their own VLAN. So we keep that concept of CloudStack where every network has their own VLAN or VNI, and we keep exactly the same concept to provide these public networks for to separate them still. I hope, I will explain. So we use a layer 2 or a shared network without any functionality, without any networking functionality. Again, with a specified VLAN, in this case the 3002. And we have our external router. So you see within CloudStack, actually we don't have any virtual router in this case. And that enables us for the virtual machine of the customer to directly talk to the external device where we have exactly the same VLAN specified or configured. So what we do for IPv4 at the moment, we provide the customer with a /20, or at least with a /29. That's the smallest unit we can give to configure all the required IPs. So we give the customer a /29 IP address, and we configure the gateway IP on our external router. And all the other IP addresses can be configured by the customer to their virtual appliances, that being to one appliance or to multiple. But that's we can directly communicate with public IP addresses. And from there on, the customer can decide if they want to route an IP address further to the virtual machine or work with private IP addresses down here. In this case, here we chose a layer 2 again without services, as in this case the customer is controlling all of it using their own firewall or routing appliance. With IPv6, we built it actually before the IPv6 was introduced for isolated networks in one of the last versions. We do it in a very similar way. Again, with IPv6, we define a transfer net, which is /64. And within this /64, we have one IP address on the external router, and we give the customer another IP address of this network, of this transfer network. And then we give each customer a /48, as RIPE recommends. And on this router, we actually route, or we have a kind of a static route, if you want to say that, of the /20 to /48 to the IP address of this transfer network at the customer side. So that way, the customer has actually two networks. One, the /64, just as a transfer network, and the /48, which they will then assign to all of their machines, to all of their virtual machines later on through the firewall router appliance. So again, it's in layer 2 network, just with the specified VLAN, and opening so many more possibilities to interact. And yeah, what's a bit annoying still in this concept is the /29. That is wasting a few IP addresses. Or when the customer only needs one or two IP addresses, you still have to provide a /29 at least. But that's the way how we do it at the moment. Maybe it will change with the rooted mode. And in IPv6, well, it's very convenient. /64 is a transfer subnet, and then a /48 or whatever you want to specify, being routed directly to the customer. That's actually, I think, in one of the few discussions on the user mailing list, I briefly touched it as well, and now that's a drawing to how we actually provide that. Geo-redundant platforms across data centers. I will just directly jump into the drawing. I think it's easier. Again, we have a CloudStack in our data center in Berlin, and we have a CloudStack in our data center in Amsterdam. And we have customers having or spreading their platform across both data centers, which is great. We encourage our customers to do so. But yeah, data exchange is always a topic. And in this case, again, we just make use of a layer 2 network. In our case, well, you could think of two different ways. In our case, we have a VXLAN based backbone, so we are actually able to stretch a VLAN, which we can do, or I was drawing here two switches to stretch the VLAN across the two switches based on VXLAN. But you can do the same with routing, so creating a VRF for the customer and route from both sides into the router. And with that, we enable virtual machines from the side of Berlin to communicate with the virtual machines on the side of Amsterdam, just by using the layer 2 network with specified VLAN. Can be so easy, just to get the idea of it, how you actually can connect them. And in this case, yeah, we've been using a layer 2 network for the public, and whatever is up there can be a DNS-based load balancing, or can be Anycast or things like that. But for the data transfer between the zones, we simply use an extended layer 2 network. Yeah.
Is there a reason why you do not use, for example, VPC to do that with a virtual private gateway?
Exactly, because then we have the virtual router in place again.
Yeah. Okay.
So we have another hop. We have the virtual router, which can be performant, but I think this one is even more performant.
Yeah.
Yeah. So yeah, again, this is kind of avoiding the virtual router where it's not exactly necessary. Yeah. And we do exactly the same. We can imagine the same graphic. I mentioned we have co-location customers, infrastructure service customers, and managed customers. So with the co-location, we would actually build exactly the same, just in the same data center, for example, stretching a layer 2 to the customer as well. And both worlds can communicate directly via this existing network without having a virtual router in the middle. Yeah.
Do you have an idea at which bandwidth the virtual router will max out for typically HTTP traffic?
I think why, and you made a test together with Alex Mattioli at some point in time. I remember some things about 300 to 500 megabits, things like that. The virtual router was capable of doing, depending on the resources you give it, right? But still, there's a latency added to it. But yeah, it is quite, or it increased performance quite well. And I'm very curious about the routed mode as well. I heard from Alex, it's a massive improvement then. Well, makes sense. And the outlook, yeah, as I mentioned, or what we were thinking of, how to improve the IPv6 deployment or providing IPv6 within CloudStack. It is already there for isolated networks and VPC and things. In that case, we would trigger on CloudStack network creation events, feed that into a Python script, and then feed that into extra BGP, and then announce those IPv6 routes, those /48, to our external router using BGP, which is a very safe way. But now, yeah, things might change with this new feature, and that is the routed mode, the static and dynamic routed mode. And with that, I hope I was able to give ideas, to inspire, to show how we are doing it. Maybe one or the other idea is helping for your cases as well. Thank you.
Maybe we have time for one or two questions, so if you have any questions.
one quick question.
Yeah.
Regarding the use of the /29, I imagine that you're doing that because there's some sort of VRRP or something like that between the routers, and you need the more IP addresses. Just to let you know, most layer 3 switches and routers now will let you use private IP addresses as the physical addresses, and then just use the virtual IP with the public, and that way you could go down to a /31 as it's a point-to-point link, and that would save you a whole bunch of addresses.
Yep, that's correct. We're exploring that one as well. We started with the /29, but exactly, the private or using private IP addresses for the VRRP might help a lot as well. Yep, thank you.
All right. Thank you very much, Stephan.
Thank you.